Hello, geometry folks. How is 7-4? I hope the inscribed angles were at least a little bit interesting to you and provide some value when we're talking about circles and kind of everything and anything that can happen with circles. So in that thought, we continue our study when we talk about tangents. Now, you've heard the term tangent before when we were talking about just the trig functions, the SOHCAHTOA, all that stuff that we've talked about before. Back in Unit 6, you had the tangent function. Okay, so that you've heard it before. When it comes to circles, tangents play a little bit of a different role, and I'll show you what I mean. Line is nothing more than a line that's going to touch a circle once. Okay, so here's a situation where we've got a circle and we've got a tangent line and we've got a point of tangent. Okay, a point of tangency. So a tangent is just a line that intersects a circle at one point. Okay, so it's not a chord. Okay, it doesn't go through the circle. It's not diameter or radius or a secant or anything like that. This is just a tangent that intersects at one and exactly one point, and the point of tangency is just where the line and the circle intersect. That's it. Okay, so now a common tangent, as you can see some examples, is one line that is tangent to multiple circles. Okay, so this line would be a common tangent. That line would also be a common tangent. It's merely what line touches the circle in exactly one point. And now a few interesting things happen when you have a tangent line. Okay, when you have a tangent line, a tangent happen. The first, before we get to that, let's look here. So we've got a couple of items. If I can draw a common tangent, so for A, I could possibly draw one right here. I could also draw one almost horizontally right here. Those would be common tangents. Okay, those would be common tangents. B, I'm looking here, and I'm looking here. And for this one, I could also see, can I pull off one that goes like that? And can I pull off one that goes like that? I'll probably be pretty close. Yeah, I think that one would have about 4 common tangents. This third one, letter C, is interesting because I'm only going to have one. That's the only one that could work for that. That is technically tangent to both circles. Okay, so a common tangent just says, you're tangent to more than one circle. That's it. Okay, so now here's kind of what's interesting. If I've got a tangent line, if a line is tangent to a circle, it is automatically perpendicular to a radius. Okay, it is automatically perpendicular to the radius that connects it. Okay, so this is helpful. Okay, helpful that I've got my my line of tangency, which is L. T is my point of tangency. It's going to be perpendicular right there. Okay, so perpendicular, when I say things are perpendicular, a whole bunch of things can become true. Let's take a look and see what we can do with this. So as I look at number 1, or I look at number 2 rather here. So is KL a tangent to circle J? How could I figure that out? Well, in order to be tangent, this would have to be 90 degrees. Okay, how can I make that work? Well, let's see. If that's 8, that's 8 because the radius of a circle never changes. So if I'm trying to see if this is a right triangle, I can run it through Pythagorean theorem and compare. Okay? Remember, if I run it through Pythagorean theorem and it works, then absolutely you can say that, yeah, that's a right triangle for sure. So if I look here, this is 64, this is 225, 17 squared is 289. A little bit of math, that makes that 289. That's equal. So I would say, yes, this KL is a tangent line, okay? And my point of tangency would be right there at point L. So yes, I would say that is the case because mathematically it works. Mathematically it's backed up. So here is GH, this one, tangent to circle F. So again, I'm seeing if this is going to work. 6 squared plus 8 squared compared to 12 squared. So 36 plus 64. 12 squared is 144. That's going to be a 100. That doesn't work. So I'm going to say no. The math just does not back that up. Okay, so let's see what else we've got. Oops, not you. So finding the value of x, assume that the segments that appear to be tangent are tangent. So let's look at this and see what we can figure out. So we're assuming that they're tangents. We're trying to figure out x. What I'm going to do is I'm going to, again, use Pythagorean theorem. And take a look what happens here. This becomes x plus 8 squared, okay? This entire thing becomes x plus 8. Okay, so that becomes x squared. That becomes 144. This, okay, I'll tell you right now, the wrong answer is x squared plus 64. That is the incorrect answer. What I need to do is, some people draw the box, some people do double distribution. X squared, 8x, 8x, 64. So that becomes x squared plus 16x plus 64. All I'm doing is adding those like terms. So now is where I kind of work. Now is where I kind of do some algebra from here. So subtract x squared, 0, 0. So now subtract 64. That leaves me with 80 equals 16x. So now divide by 16. So x will equal 5. So that's my answer, 5. So now the hard part is making sure that my setup is correct and making sure that I multiply x plus 8 correctly. Okay, so for letter B, over here, so that's going to be x squared plus 14 squared equals 17 squared. So that's x squared plus 196. 17 squared, I believe, is going to be 289. So now I work from here. 289 minus 196 is 93. We know 93 is not a perfect square root. So if you left it as square root of 93, that would be fine. I wouldn't count this wrong. If you wanted to give me the big decimal, I don't hate that either. I don't love it. 9.64. I like this better. This is a little cleaner. Square root of 93 rather than some big, long, gaudy decimal. Okay, so another kind of application here is if I have got two segments that are both tangent to the same circle, okay, those tangent segments are congruent. Okay, so here, AB is congruent to BC. Okay, AB and BC are tangent to circle D. Okay? So if A, B, and C, D are tangent, they're congruent. If they're congruent, they're tangent. It works forwards and backwards. So over here, they're both tangent to circle D. So this is pretty straightforward. They're equal to each other. A little bit of algebra later. 0, 0, x equals 20. There's my answer. There's my answer. Over here, number 6, same idea. 3x plus 8 equals 26. So 3x will equal 18. X will equal 6. There's my answer. Okay, a term to be familiar with is called circumscribed. Circumscribed just literally means that the circle is on the inside. Okay, and the circle is going to touch, if you notice, the circle touches every side of the shape. Okay, circle touches every side of the shape. That is what makes it circumscribed. It has to touch every single side of the shape. A couple examples of what doesn't work. If you notice, this one's not even all the way inside the shape. This one's inside the shape, but you notice there's a gap here that it doesn't touch. And this one, there's no touching any of the sides, so none of that works. That doesn't work. Okay, that is not circumscribed. Circumscribed is all the way inside, but touching every single side. So there's a little bit of a distinction you need to be familiar with. Okay, so if it's circumscribed, that means that all of these are tangent because they all touch once. So if this is 3, this is 3, this is 3, this is 3, this is x, this is x, this is x, this is x. The perimeter is going to be 18. Okay? So it's going to be 4x plus 12 equals 18. Subtract 12, 4x will equal 6. So x will equal 1.5. There's my answer right there. There's my answer. Okay, so because these are all tangent. Okay, not too many terrible ideas, just kind of using the Pythagorean theorem to see if lines are tangent, and then seeing what can happen if I have two lines that are tangent, and kind of playing around with that idea. Okay, so next is the 7.5 assignment and the 7.5 quizzes. All right. Thank you very much, and I look forward to answering your questions.